Very exciting to be here today. I've just looking around the audience today and talking to everybody yesterday. This has just been a phenomenal conference, and I'm really excited about being here today. We're taking a little bit different tangent on this presentation because we're not going to be really talking a whole lot about Gen H2. We'll be explaining some of the work we're doing here, but the main reason why I was asked to come here and address some issues is talk about liquid hydrogen. So I'm going to talk a little bit about liquid hydrogen, how it's being utilized today, and how we're going to go forward. So I actually like to walk around, so I'm going to try to do this. Check. Yeah, good. Excellent. So once again, my name is Cody Bateman. I've been doing work, basically my first rockets were designed in 1985. Had the privilege of working with DOD, DOE, and a lot of work with NASA, especially in the last 12 years. So one of the things I'd like to do to start out with is these conferences like this are so incredibly important because you keep talking about collaboration. We'll be talking collaboration a little bit later in the speech as well. But really, it's all about the organization of events like this. So I want to do a special shout out for the ALJ group. I thought this was extremely well run. The food's been great, the networking's been great, the platform's been good. So thank you very much. So I want to start out by just talking about the history that we all know and where exactly did the hydrogen infrastructure and everything come from initially. So most of the people at Gen H2 have had some association, especially with NASA. And so it's interesting that if you look at some of the first uses of industrial hydrogen is actually for the space program going way back. So we don't really want to dive into that too much, but it's interesting to note that we know we really started at a large scale with liquid, and now we're getting back to it after all these years. There's a great book out there, Taming Liquid Hydrogen. This is a great book that I just love the terminology of taming liquid hydrogen. So everybody here at this conference knows hydrogen's hard. There's nothing super easy about it. And once you go from gaseous to liquid, it actually becomes more and more difficult. And so, taming this liquid hydrogen has been considered one of the best and biggest accomplishments of NASA. The space program's really cool, all the missions have been cool, but the thing is the whole purpose of NASA was to give stuff back to not only the US, but the world economy with great technology. And so what we're seeing now is we're taking a lot of the really cool information and technology that has been developed over decades at NASA, and we're pulling them together now and then turning them into commercial use. So it's not just Gen H2. Everybody in this room has access to NASA technology. I'd highly recommend go out there. There's a technology transfer program you can go out there to see. One of the things that we do at Gen H2, we actually work with everybody that's basically in this room, anywhere globally as well, except for a few states or countries that can utilize this technology. So I just want everybody to be aware that there's great information, great technology out there for everybody to share, thanks to the US government and everything put into hydrogen over the last 4 or 5 decades. So I'm going to start out with production. So one of the things we've been talking about, and you've seen a lot of people here, is talking about hydrogen production. And everybody's very familiar with the large-scale production. So we're talking about the huge hubs out there. We're talking about these massive sites, but there's only a dozen of them, maybe 20 or 30 in the next few years. But these sites are going to be few and far between. The key is, though, in the hydrogen world, we also need it at lab scale, which means small amounts of hydrogen are needed to do the initial testing, certification, and validation of a lot of the technology out there. And this is something that is just now starting to be addressed. So if you go to Asia, you go to Europe, it's actually not too difficult to get small quantities, especially of liquid hydrogen. But in the United States, it's extremely difficult. So as we move forward, we have to look at not only this massive high-scale production, but stuff for the labs. In addition to that, we have a great partner of ours, PDC's here. They work with Simple Fuels. Now I love this because this is production on site. It's very small. It allows you to do production and storage and dispensing on a very, very small footprint. And as you look at these massive hubs, you also have to look at these smaller units and where they fit in a total hydrogen economy. And that's really the only way the hydrogen economy is going to take off by the 2030s, 2050s, is going through not only the big hubs, but the smaller units. Another smaller unit, it's also to think about production, is other ways to generate hydrogen. And a lot of people discount these ways. This is Bo Max, they're actually in the Space Life Sciences building with us at NASA. But this group has been working with finding ways to create hydrogen. And right now it's at a micro scale, but there's also that potential. So as we're talking about green hydrogen, we have to look at there's other forms of production for green hydrogen other than solar and wind. And we have this new technologies constantly coming out. It's really exciting to see about. Then we also have this project here. So I don't know if y'all noticed this. It's been in the news just recently. But this was a very interesting case that I really enjoyed doing the work that I did for the Department of Defense. How do you create hydrogen in a very remote location? How do you pull that off, and you can't carry the hydrogen with you? So this project was done by a group at MIT. It's called TARP. Highly recommend that you look at it. It's really exciting ways that most people don't look at hydrogen production this way, but they basically use aluminum. They can actually go out to a field on a backpack, create the hydrogen for drone use. Really exciting. And then lastly, I get asked all the time, what's Gen H2's role in hydrogen production? So we're primarily known for liquefaction and storage, but we also have all this really cool technology, once again, from the US government that we're pulling together. And so we're constantly researching new ways to create hydrogen. And we have a pyrolysis process here that we really like that creates not only hydrogen, but carbon black as an output. But this is just one of many different ways of creating a new form of either turquoise or green hydrogen there. So it's very exciting stuff we're seeing on the developments on that. The cool thing, what we're seeing though, and the reason why we're doing what we do in hydrogen production, is the fact that we're coming up with all the new tools and techniques and ways to monitor and make hydrogen more safe. And so we use a platform for hydrogen production for us to grow and expand our own knowledge. And this is something we like to share with everyone in this room. So let's talk about the case for liquid. So that's the main reason why I came up here to talk today. So everybody's talking about why liquid. Everybody's doing a lot of gas out there. But the bottom line is hydrogen's hard, right? And liquid hydrogen's even harder. And so there's different ways of looking at how to make this work. So why liquid hydrogen? Bottom line is power density. So if you look at the number of semi-trucks that can carry, that's necessary to carry the same amount of power, it's like 14 and a half actually trucks required that's equivalent to one tanker truck of liquid hydrogen. And if you're looking for different uses, it's very important to have as much power density in as much small area as possible. You can't just have these huge gaseous forms. The second point is safety. And so what a lot of people don't know, even in the industry, don't understand how much safer liquid hydrogen is than gaseous. And there's a lot about to be said about that in the future. There's a whole lot written about it. We'll be talking about a big event going on next week that talks about this specifically. And then third is, what is the major drawback? And that's what everybody looks at us and they say, well, not only is hydrogen hard, it's very, very intense use of energy to get the liquid and then store it long term. And that being said, the interesting thing about the storage is that we actually have to customize each solution. There's not one size fit all when we go forward with this. So we'll get to that in a second as well. But liquid is obviously the best solution for certain applications. The first, of course, is heavy-duty vehicles. So if you're going to do a long-range semi-truck, you want to go we don't talk about trucks, trains, and trash, right? So imagine a school bus. Is it better to have that in liquid or gaseous format? BEVs sometimes don't work out. You still have long school trips, and once you get to another school somewhere, you may not be able to get back home if you just do battery electric. The interesting thing here about these trash trucks is very interesting. We were working with a company that does battery electric. And by the time they got all the power necessary to not only drive the truck, but then to compress the garbage, there was no weight left in this trash truck. It was a beautiful truck, But imagine a trash truck that couldn't carry trash. And the only way to solve this is through using hydrogen, and specifically liquid hydrogen on board. The second one is light rail. So it's amazing to me how few people understand that a standard train, not just a light rail, but all big trains are actually diesel electric, which means the diesel engines generate the electricity to run forward. So it's very true for these light rail systems, because a lot of those are in urban areas and you're trying to minimize pollution inside major cities. The light rail is a perfect fit for hydrogen. But once again, the size and space of storage comes in effect. So by having liquid hydrogen on board, it makes the light rail systems a lot more likely to happen in the short term. Another one is ships. If y'all been watching the news lately, we had a big shipment that goes from Australia to Japan recently. This is the future, not only of shipping hydrogen, but actually using hydrogen on board. And using hydrogen on board for a carrier, for cruise ships, makes a lot of sense. So all this technology is coming about too. And the reason why I'm bringing up all these three options right here is primarily to let people know it's not just about passenger cars. And I really do believe the future of hydrogen is going to be on these three topics primarily. But the fourth one is coming up very, very interesting, and we're seeing a huge demand for this. And it's not just military drones, we're seeing commercial drones and needs for drones to be done on liquid hydrogen. So a couple of years ago, we actually are working with a partner of ours that had the world-breaking longest flight on a drone, hydro-powered drone. It was more than 12 hours long. This year, we're actually working with two partners, and GenH2 will be part of a world-breaking drone flight carrying a 5-kilo payload, and we'll be doing that in June. But the 5-kilo payload, the reason why that's so important is because you can carry cameras and other equipment on these drones. These are not your standard drones. These are actually fairly large. And the interesting thing about that, the great thing about drones actually, is the fact that you have other challenges involved. So if you're having liquid hydrogen, of course, as the liquid burns off, you have weight distribution issues. We have to address those. We also have to worry about vibration, because everybody here knows that we try to make hydrogen happy. And the more agitated hydrogen gets, the more it wants to release the energy that's within it. So those are some of the issues we're addressing with drones. So one of the main reasons why I love liquid is the purity factor. So we've done a lot of work with BP, and it was interesting. They have a great story that says when they first came up with their first hydrogen filling stations in test mode, they lined up 3 fuel cell vehicles, they lined them all up, they filled them up, they drove about 100 yards, and they all stopped. And what they didn't understand was the purity level required for the fuel cells was significantly higher than what they anticipated. And so the cool thing about liquid hydrogen, just by the fact of liquefying it, you get to be 7 to 8 nines deep. So it's very, very pure, clean enough for almost any fuel cell. So that's the great thing if you were to build filling stations, especially for planes and trains and trash trucks. You need that to be very, very clean, and that's guaranteed by using a liquid format. Secondly, we have actually worked with a lot of gaseous hydrogen solutions as well, and we constantly look at the cost of purifying the gaseous hydrogen. And that's a cost a lot of people don't factor into it. So when they say liquid's a lot more expensive, it's a lot more hard, they take out this out of the equation. So really, when you look at the net, what it takes to generate the hydrogen, you also have to add on not only the gaseous storage, but also the purification that's required. So there's a lot of costs involved in that. But one thing else too we like is that, as I mentioned before, that the liquid completely eliminates this problem. So my daughter's an attorney, and she's used to doing a lot of litigation. The interesting thing is too, that we look at this, we look at the purity, as a company that's selling hydrogen, you don't want to be sued because things have gone wrong. If your source comes from a liquid source, a lot of litigation goes out the door immediately. You don't have to think about it. Somebody can't say your hydrogen was unpure, so therefore you owe me a new car. So we're going to look into a lot of cool things going on with that as well. So liquid storage solutions is something that we specialize in at GenH2. So liquid storage has been around for decades. That's obviously was what was used there at NASA and for the rockets. But the hard part for liquid is not when it's large, it's when you scale it down. And that's really why Gen H2 was formed 14 months ago. It was like, how do you do the impossible? How do you do something below 10 to 15 tons in size? So we were given the challenge to look at, can you build something at 5 tons? And we said, yes. We have a great solution for building a 5-ton solution. And then they say, okay, let's get it even smaller, because you're gonna have smaller footprints, right? You're gonna have these gas stations that can afford these huge 5-ton units. And so we came up with our new 1-ton unit as well. So the thing is, it's not impossible. A lot of people come to us at this conference, we're buying parts from it, we got vendors here, we got one of our VC groups here that we're talking to, and they understand that ultimately, if we're going to use liquid, we're gonna have to make it smaller and smaller scale. So we've come up with about the 1.2 tons is probably the lowest size you want to do for a liquid solution. But I just want to give a shout out. We had great meetings with Chart yesterday. We are engaged with Chart, so thank you, Chart, once again for sponsoring the event here, being the premium sponsor for the event. But Chart's been doing this for a very, very long time, and just a huge shout out for these guys because they have really worked with us to optimize these tanks and create things that, once again, people said couldn't be done. The little tank up here in the top is actually one that's a preliminary design. We're actually doing a lot of work with Shell. So it's interesting to see that not only are companies out there looking for us to do liquid, but the big oil and gas companies are trying to find ways and inject and doing work with us as well as creating new liquid solutions. So what's the path forward? Where do we go from here? So the thing is at these shows, and what I really like is everybody's talking about collaboration, how we fit together. But the cool thing is that we need to all come up with a recommended proper solutions. And so a year or two ago, when the hydrogen economy was taking off, what we saw was a lot of people were just saying, this is my way or no way. No, just pick my company, don't work with somebody else. And that's not a path forward. And what I'm seeing at this conference is everybody's going around and saying, look, I may not be the best fit for you. We actually had dinner last night, and it was great to have a vendor saying, I'm not the right fit. And I love that, because instead of just trying to pitch something to sell something, because this economy is so huge and growing, it's great that people are willing to step up and say, look, I'm doing the proper solution. So I really challenge everybody here as you move forward, do what you do best, promote what you have that's good, but also understand your limitations. Secondly is a unified message. That's something that's very, very new. So we had the conference last June, and just in the last year, everybody in this room is starting to say the same thing. If you've gone to a lot of these seminars, everybody's talking the same way. We're using the same language. And that is actually very good, not only internally as an industry, but it's also great for the outside world. So as you do press conferences and everything, as we go up this unified language, that's why I love these conferences. We're all speaking the same thing. That makes the hydrogen economy better for all of us. And something you've heard over and over again, and David just brought it up in his last talk, is collaboration, which is exciting. It's very exciting for us. It allows us to all go and share information, share experiences, share safety regulations and everything moving forward. But the main call for me is what you'll see I do quite a bit, is I speak outside of hydrogen conferences. I talk to people that are not hydrogen savvy. You have a lot of people talking about the green economy and going green, but there's not a whole lot of people out there evangelizing this, going out and being very, very passionate. And I'm starting to see the passion grow and rise here, and it's very exciting for me to see the amount of excitement coming up from everybody in this organization. So where do you learn more? There's a great conference next week. If you don't have this already on your calendar, if you want to learn a little bit more about liquid hydrogen, highly recommend that you go here. If you don't take a picture of this or know it, just contact anybody at Gen H2. We'll be able to give you some details here. This is just an amazing conference that will go over everything I just talked about in 15 minutes. You'll be having 2 full days, actually I think it's 2 half days, of conferences on liquid hydrogen. This is going to be great for people to go and learn to see where the future is, because I think ultimately the future is going to be liquid. And these are the top guys. These are the people in the Department of Energy, H2 at Scale, and NASA. So basically, Gen H2, we just want to welcome everybody to join us. You'll see this in a lot of presentations. At Gen H2, we are commercializing a lot of really, really cool technology. So we do have some products that we're going to be making commercially available, our end-to-end filling station solutions, some of the liquefaction and storage solutions, but we're also excited about all the pieces and parts and components. So we're very active. I think we're the largest company that actually licenses and distributes technology from NASA. So if y'all have special needs, especially some of the parts manufacturers here with valves, if you need somebody to help with testing and validation of cryogenic equipment, please let us know. This is the patents and license that we have. And then lastly, the advanced R&D. So this is something I just don't want anybody to be settled in on. We're just now kicking off the hydrogen economy. I know we're rushing to get to end solutions. There's a significant amount of R&D still required. There's tons of government grants going to be going out. There's some going out just recently. I do recommend that everybody here to get together. We were asked to partner on 2 different events this week. So, you know, I'm really looking forward to meeting people. That's one thing I'm taking advantage of this conference, is being able to go out and say, oh, look, as we bid on these government contracts, let's get together, let's collaborate, and let's move forward. So once again, thank you very much. My name is Cody Bateman. We have a booth here at Gen H2. Love for y'all to come by.
Your thoughts were well received, Cody. Very high energetic presentation. So big round of applause from me as well. And it's great to know the widespread offerings of Gen 2 technology as an energy carrier for backup power generation. I was writing it down. Fuel cell supply, clean energy source, transportation, drone, oh my God. The list never comes to an end. And I cannot agree more with you on the collaboration component. That is indeed very pivotal at this time. So I see we have a lot of questions in Slido, but they are on the final details. So let me ask you one broad question, and then we'll go through the Slido screen.
Sure.
So in context to my opening remarks today, as I mentioned, Cody, in my opening remarks, that with major expansion within hydrogen infrastructure and distribution, safety will be paramount and it will be pivotal. So how do you think at Gen H2 you guys are taking, or maybe what is the roadmap to evolve around the already existing safety procedures and codes and standards?
Absolutely, yeah, so there's quite a bit of different answers to that. And so one of the reasons why we went to liquid is that liquid was significantly safer, especially in extremely large quantities, than gas. And in addition to not only liquefying it, it's also leak detection is a huge thing. And so we have a couple companies looking at that. But I do foresee in the next 2 to 3 years, the amount of technology associated specifically with leak detection, ventilation of the units and how they're set up. You'll see a lot of advances there. Plus, it's really good with companies. We were talking to some groups that work on regulations. And so some of the new regulations out there were way too strict initially. They kind of eased off and they're coming back. And so what we're doing at Gen H2, we're trying to right-size the regulation. We're working with different state governments to talk about as they implement hydrogen, what is the level of safety? Because that really is a big concern for people. They have this wrong, thoughts of how dangerous hydrogen is. And so it's kind of dispelling that myth.
So again, the component of collaboration with the industry, which will be pivotal to evolve through the codes and standards.
Right.
Okay. So I see a lot of questions. Let me make it very simple for you. I'll pass on the Slido screen to you, and you can, in a sense of time, maybe pick one or 2 questions of your liking.
Okay, I'll go for the first one here. It's the one that has the most questions on it. How is liquid hydrogen at minus 425 stored in trucks considering boil-off losses? Is it special low temperature, metallurgy? Well, that's actually a better question for Chart. These guys have really nailed that. We also work with CB&I on cryogenic tanks. And so the interesting thing is boil-off is a big issue we all have to address as soon as you're transporting it, right? So the boil-off, obviously, you don't know, has a lot of pressure builds up, that hydrogen has to be released. The interesting thing is you're going to be seeing on the boil-off, especially if the truck itself is a hydrogen-powered truck, you can use the boil-off to your advantage. You take the boil-off, you run it through a fuel cell, then you can actually repower the batteries on the truck that's taken down. So you're going to see some really, really cool technologies as far as that goes. We have some really good new stats on trucks on how long the liquid hydrogen can stay on the truck. You're starting to see that expand, which gives us a little bit longer distances. You'll see a lot of companies, though, there's still, when you talk about the hub and spoke, I think the safe limit that a lot of people are looking at is still about the 100-mile radius. I think realistically, in the next year or two, you'll be at a 200-mile radius. But the point is, that's one reason why we're trying to do a lot more hydrogen production on site, is to minimize transportation costs. So if you go to California and you're buying liquid hydrogen at the pump, almost all of those, I think there's only one that actually does hydrogen production on site. And what you're seeing is that transportation cost of the hydrogen is why the hydrogen is so freaking expensive. Is that enough?
Yeah, I believe so.
Okay, thank you very much. Thank you all, everybody.